Part A asks to find the derivative of arc cosine x over 2. The derivative of arc cosine is actually found in the formula booklet. Now we have to deal with the inside function x over 2. This will require us to use the chain rule. The chain rule says that we need to multiply the derivative of the outside function, so in this case arc cosine, by the derivative of the inside function, so x over 2 here. Our final answer would be minus 1 over square root 4 minus x squared. Part B asks to find the integral of arc cosine x over 2 from 0 to 1. We can rewrite the singular function as the product of two functions, 1 and arc cosine x over 2. This is important because we will now, you guessed it, use integration by parts. Here is the formula from the formula booklet. Now we need to decide which function, 1 or arc cosine, will be u. Generally, we need to make u equal to the function that can be differentiated but not integrated easily. So arc cosine in this case is the likely candidate. So we already found the derivative of arc cosine in part A, so we can just copy this down. Meanwhile, v prime will be 1. So that means that v will be x. We can now use these values and plug them into the integration by parts formula. First, we'll multiply u by v, so that would be x arc cosine x over 2. Then we subtract the integral of v times du, so that is also known as u prime. And that would be x times minus 1 over square root 4 minus x squared. So now all we need to do is solve this second integral. We can do this with a u substitution. We can substitute what is inside of the square root, so 4 minus x squared, then find the derivative of this u, and that would be minus 2x dx. And if we notice, x dx is already found in the integral, so we can substitute this for du. And remember, do not forget the minus 2, so we have to multiply by minus 1/2 in order to maintain the value of this integral. We have replaced 4 minus x squared with u, so our integral will look like 1 over square root of u du times minus 1/2. Since we have made a substitution of the variable from x to u, we must now change the limits. We do this by substituting the limits into x and solving for u. This means that the limits will be 4 and 3. Now, the negative integral from 4 to 3 is the same as the positive integral from 3 to 4. And 1 over square root of u can be rewritten as u to the power of minus 1/2. Now we can use the power rule to integrate this integral. And we can copy down the other part of the answer. Remember that this part of the answer was also an integral with the limits from 0 to 1. So now we can use the fundamental theorem of calculus and substitute the upper and lower limits into x and subtract the two values. Cosine is 1/2 at pi over 3, so the answer would be pi over 3 plus square root of 4 minus square root of 3. So that's it for this video. Thank you for watching, and I hope I helped you with this question. Please like and subscribe. Bye!